Huh?
Oh, hey, I got a
Shotgun?
phantom.
No, with a
Oh
knife.
my god.
Water take him,
I don't know if you
Texas.
saw
Knife
that.
the turret and then shorty from a million miles away.
It worked though. It distracted her.
work.
She
It
was
did
looking at
work.
me, and then Abe got her. It's kind of a little bit of a team thing.
Woohoo!
Wait, Jenny, she's still on the stinger only. Yeah.
This is for fun though. We're all friends
No,
here.
this is serious competition.
Yeah, I mean, this is worth more than a ranked game.
No.
Listen, I'm gonna be silver for the rest of my life, but I might win a couple in-houses, and I'll remember that.
Oh.
Wow.
Oh my God, Ryan! Jesus!
Oh.
He's going. He's
Look at
he's
Ray.
snapping on
You're
him.
making them mad.
Oh shoot, we don't want that.
Oh.
Okay, maybe I should have stopped. Like, no, I probably should have stopped, but
Yeah, you unfollowed Leslie on Twitter?
oh. Ooh. Why'd
Hey,
you
just
unfollow
who,
her on
Leslie?
Twitter?
I don't recall
Why?
doing that.
Maybe he thought it was a fake account because it was unverified.
True. I'm not gonna follow this imposter. Me.
Yeah, that makes sense. That makes sense.
Welcome to another CI/CD episode. This time, I'd like to show you how you can use Docker and GitHub Actions to automatically generate or build a binary file from your source code. And then that binary file lives on a GitHub repository page that users can download and flash to their own embedded system. This is known as continuous deployment. We've been looking at this CI/CD, or continuous integration, continuous delivery pipeline, and we've seen this slide before. In this example, we might have some event. For example, you might push a new commit to a GitHub repository, and the first workflow might execute. And this is just a job that builds the project and perhaps performs any unit tests, which is something we looked at in a good amount of detail in the previous episode. And then maybe you have some sort of integration test where you try to run the application or program in its entirety. This is a little difficult to do in embedded systems because often that requires running on the hardware. Now, you might have something like a hardware in the loop test where you actually take the compiled binary, you push it to, say, something like a small server, think Raspberry Pi, which is connected to real hardware. That pushes it or flashes it to the real hardware, runs any tests, and then gets any results and pushes this back to, say, GitHub. This is known as hardware in the loop, and it's more advanced than what I would like to cover in this series, but feel free to look up hardware in the loop and you can see some examples out there. I'd like to focus on the next workflow in this episode, which is the delivery phase, where we talk about maybe building the project again, performing any final quality assurance checks or QA checks that might require a person to look at the code and to examine functionality before they give their final approval. And after that, once approvals are had, everything gets deployed. And in many cases, you often see CI/CD written about or talked about in the context of deploying to, say, servers or end user applications that run on a computer that gets updated automatically. And this idea of updating applications automatically is usually what you hear about when people talk about continuous delivery or continuous deployment. This is a little more difficult with embedded systems unless you have something like over-the-air capabilities. But for our purposes, we're just going to focus on that final workflow where we just want to create a deployment. And this deployment really is just building a binary, this compiled binary, that's going to sit on our GitHub page that users can download without needing to download the whole source, build the whole tool chain, compile everything, and then get the binary to flash to their device. We just want to make it easy for users to click on releases, click on download binary, flash to their device, and you're good to go. So to do that, we're going to create a Docker image, and we're going to use Docker because we can create this container that users can also run locally if they want to build everything without having to install the full tool chain. The Docker image will contain the tool chain. They just need to run that Docker image and copy out the binary. But we're also going to run that Docker image or run that Docker container inside of a virtual machine in GitHub Actions. We're going to create a workflow around this that will create the binary. It will automatically copy that binary out and then create a new release with that binary that automatically shows up on our page. All we have to do is just create a new tag, check in that tag using the git command, and this whole workflow will execute, creating a new release for us. To start, go to github.com and we're going to create a new repository just like we've done in previous episodes. I'm going to call this one Pico Deployment Demo, specifically because we're going to demonstrate how to deploy embedded firmware that's been compiled for the Raspberry Pi Pico. And as you will see, the Pico happens to make this automatic deployment fairly easy, although you can do this with other embedded systems. Let's create this repository, and we're going to bring up our terminal. In this case, I'll be using git bash because I'm on Windows, but as long as you have the git command line tools installed, you should be fine. Go to wherever you keep your projects, and then do git clone and the location of your repository. I will let that clone. It's going to be empty, which is fine. And I'm going to go into that repository. I have a separate series on getting started with the Raspberry Pi Pico and the RP2040. I recommend checking that out if you'd like to know how to develop for the RP2040. And we're going to be using the basic Blink demo that is part of that series and that tutorial. And we're also going to be using CMake and the CMake file. I won't go into how to develop for the RP2040 because I already have a series on that, so I recommend checking it out. But we will be using some of the code from here. So let's copy this. And let's go into our repository folder, which is the Pico Deployment Demo. In here, we're going to create an SRC folder. From here, we're going to create our main.c. We're going to open this with whatever editor you choose. We're going to paste that in. All that's going on here is we're going to include the standard library from our Raspberry Pi Pico SDK. All we're going to do is set the LED pin to 25, which should be the onboard LED for the Raspberry Pi Pico. We're going to initialize that LED, initialize the serial port, and then print out blinking to the serial port, turn the LED on, wait a second, turn the LED off, wait a second, and repeat that whole process. So let's save this. The other thing we need is a cmakelists.txt in order to tell the Pico toolchain how to build this. So go back to this getting started guide. Here's an example of that cmakelists. So let's copy that. We are going to create cmakelists. Note the spelling here, it is important. So capital C, capital M, and capital L, and it's all one word. Let's open that with Notepad++, and we are going to paste in our CMake commands. All we're doing here is setting the minimum required version of CMake. We're going to include the Pico SDK. We're going to set the name of the project. Note the name of the project is Blink. This will come up later when we go to generate our executable or our .uf2 file. It will be named blink.uf2. So if you change the name here, that will change the name of your binary that you need to upload. We will initialize the SDK, which this is essentially just a function inside the SDK CMake stuff. We'll tell CMake where to find our executables. We'll add any other source files that we need here, and then we will tell it to create the binary file. Specifically, we want the UF2 because that makes flashing very easy on our Pico. We will link to the standard library, which we need thanks to that standard lib.h. And then we're going to enable our serial output via USB by setting this to 1, and disable the UART by setting this to 0. If I remember, you can only have one of these enabled at a time. So if you have pins connected to UART, or if you're using the pins for the UART, then you want this to be 1. But if we want serial to go out over USB, then we want this one to be 1. So that's a quick refresher on developing for the Raspberry Pi Pico. Let's save that. One of the reasons I like the Raspberry Pi Pico so much is because setting up the toolchain is very easy on Linux. It's really not easy on Windows, but Linux and Mac is very easy. So if you go to the Getting Started with Raspberry Pi Pico official Getting Started guide, that you can find on the Raspberry Pi site. Go to the table of contents. We're going to go to chapter 2, which describes how to set up the SDK. Note that they tell you how to set it up in Linux, because I guess they're using something like a Raspberry Pi and not Windows. But we're going to use Docker, and we are essentially going to perform these commands inside of a Docker image, which makes this process modular so that you can give a Docker image to somebody to build your code, or even better, we can put it inside of GitHub Actions to automate the build process for us, so that whenever we say check in new code, it just creates a new UF2 file that somebody can download. This is how we're getting into the whole continuous deployment side of the CI/CD pipeline. So take a look at these commands. We're essentially going to use these, where we're going to clone the whole SDK. We don't need the examples. We're going to install the tool chain just by using the apt update apt install. We don't need to update the SDK, but with everything there, we can link it all together and then build our source code inside of a Docker container. So to do that, let's go to our repository. We're going to go up a directory to the root of our folder here, and we're going to create a Docker file. That's fine. Let's open that with Notepad++. And as we've done before, we're going to start with an Ubuntu image, since that's generally pretty easy to write. And the newer versions of apt2, we don't actually have to call apt yet, so we can just call apt update and apt install. You see here, I'm creating a list of commands that will be run during image creation that allows us to install the necessary packages. I recommend watching the first episode of this series to understand how to write these Docker files. I'm essentially just using the same commands from there in order to create an image for building Raspberry Pi Pico binaries. All of these prerequisites are coming from this Getting Started guide. So if we go to the toolchain, this is all that I'm installing. Note that there is no sudo with these images, so you just want to pull this line here. Remember that the double ampersand means that when you execute a command and then execute the next command, the backslash means that this run command has arguments on this line or on the next line. So now we've installed essentially the toolchain. Next we want to install the Raspberry Pi Pico SDK, so we're going to create a directory called project, and in that we're going to create source. We're going to go into project and clone the SDK in the project directory inside of our image. So we go back to here. We can see where we're starting to clone this. We don't want the examples, not the one that I'm highlighting. We want the location of the SDK. So let's paste that here. And I forgot to add this line, or this parameter, which is the branch master, which is the branch we want to check out. That should be by default, but just in case. And then I forgot to say we are continuing on the next line. We want to go into that directory, that Pico SDK directory, and we want to initialize all of the submodules inside of that directory, because that Pico SDK repository contains sub-repositories that it also has to pull down, or potentially other places, but I believe it is GitHub. Then we're going to go back to root when we're done with that section of the install. If you worked through the Raspberry Pi Pico Getting Started guide, you will probably remember that we need to set the environment variable as a task, because when we call CMake, it looks for this environment variable to be set in order to find where that SDK is when you go to pull in headers and other source files from that SDK folder. So to set an environment variable in Docker, we just use this env command and set the environment variable there. Just like any good CMake system that you might have set up before, if you've played with CMake, we need to first create a build directory inside of our project directory. We're going to go into that build directory, call CMake ... which means call it from the context of the directory 1UP. Once CMake does its thing and creates the make files, then you call make inside of that build directory, which will build everything and then drop the source files in that build directory. To clean up, you would just need to delete that build directory, but since we're inside of a container, that means we can just extract that UF2 file and then delete the whole container when we're done. No need to do any nice cleanup. Docker requires us to have some sort of entry point If we try to leave it blank, it will yell at us, so we're just going to say that the default entry point is bash, and that's fine. We'll leave it as that. So let's save it, and now we are going to try running the Docker process locally before we create a GitHub Actions around it. So make sure that Docker Desktop is running. Go into your repository directory. From here, you should see your Docker file, and we're going to create a Docker image called Pico Builder Image from the context of this directory, which it should find that Docker file. It looks like I got an error here, and when I go back to my Docker file, I forgot something very important here. So even though we set the environment variable, the one thing we forgot to do was to copy in our source files. So cmake and everything else is going to fail. Let's use that good old copy command. We're going to copy things in from the host machine's source directory into the images project / source directory. So let's save that, and we will see if this runs again. Wait just a moment while that runs. With the image built, let's create our container. I'll call docker create. I'll name the container Pico Builder Container so that we can use it later. Build it based on the Pico Builder image. Note that in the image, it should have already built the UF2 file. So let's take a look at that Docker file one more time. So this make command builds it in the image. So all we have to do is fire up a container and then copy out whatever binary we want. So now that the container is created, we can use the docker cp command. We'll look inside of the container we just made. And in there, project src build, which is where the build directory should have been made. And we're going to look for blink.uf2. And we're going to copy that to the local directory, which is in our current repository. We're going to copy that out to blink.uf2. So now, if we go and look in our directory, sure enough, there is the built binary for our Raspberry Pi Pico. And if you have the Raspberry Pi plugged in, you can just copy that here. But let's first create the GitHub Actions so we can automate this whole process before we actually test this on our computer. I'm going to remove this file. Let's create a basic ignore.
From imperfection, we build a new
So you can see this in action, what you might do for a real repository. And because I'm going to use this repository as a demo, I want to make sure some things are not checked in. I just went online and found a basic git ignore that recommends certain files to ignore for C, C++ projects. And what we care about is not checking in compiled object files and any of the executables. For our purposes, this is mostly the .uf2, but just in case, we might have ELF files, binaries, especially if you're doing things for embedded systems, .app files, .out, things like Linux, and then .exes for things like Windows. So that should cover us for most of the basic stuff in this project. In a previous episode, we went over GitHub Actions. So if you haven't seen that, I recommend watching that to understand what's going on. So to create an automatic flow or a workflow within GitHub Actions, we're going to create a folder in our repository. We're going to call it GitHub. And the naming here is important because GitHub looks for this directory to be present. And within here, it's looking for another directory called Workflows. So we go into Workflows, and here is where we can create one or more workflows. The workflow we're going to create is called deploy.yaml, YAML. I'm going to give it the name deployment version. In the episode where we went over GitHub Actions, we made it so that the action or the workflow would execute every time anything was pushed to that repository, any new commit. This time, we're going to only execute this workflow when the tag is pushed. And specifically, we want to look for a tag with the v something.something.something, and this essentially creates a workflow process where you need to create a tag that is a version number, so like version 0.0.1, which is what we're going to start with. As soon as a new tag is pushed with this particular template, then this workflow runs. So you can push commits all day long, and this won't run until you create this new version tag. And this is going to help us so that new UF2s aren't pushed if you're just trying to push a minor change and you want to test something. You actually have to specifically want a new version. We can create an environment variable inside of our workflow here by using the env command. And we're going to set this capital app name, and we're going to use blink. Note that blink should match whatever we set in the CMake lists that I showed you earlier. So if you change that name, you got to change this one too, because it's going to look for blink.uf2 in just a second here, and you'll see that. By default, workflows do not have write access to your repository. So when we generate that UF2 file, we actually want to write that UF2 file back to the repository so that it shows up in our releases. We're going to run this workflow on the latest version of Ubuntu. So this is going to happen in a virtual machine on GitHub. We're going to name this job, build, and deploy. And we're going to do a number of steps. The first thing we're going to do is check out this repository. And remember that these dashes indicate a new list. So this is a group that executes together. We're going to name it, and we're going to use the checkout GitHub action. As a quick refresher, if you go to github.com/action/checkout, you can see what this checkout action is. And when we call uses actions checkout v3, it's just going to run this action, which allows us to check out our own repository into that virtual machine, that Ubuntu virtual machine, so that we have access to all of our files, at least the most up-to-date files. Just as we saw earlier, we're going to build that Docker image inside of our virtual machine. Next, we're going to create the container based off of that image, because the image itself should actually contain a compiled version of our Pico program. And as we saw before, we want to copy out the UF2 file, which we named blink.uf2. But instead of hard-coding blink.uf2, we're going to use this variable that we created up here called app name. Remember that this must match what we set in project in that CMake lists. So it's going to look for blink.uf2 inside of the project source build directory, and then copy it to our virtual machine, the Ubuntu virtual machine, to whichever directory is running these commands. Inside of the virtual machine, it knows about this environment variable we set called app name. When we go to push the file to GitHub, which is out there on the internet, GitHub does not know the name of app name. It does not know the blink that we've stored here. So in order to set this variable so that GitHub can read it, we're going to create a line that sets lowercase app name to whatever we have for uppercase app name, which should be blink. And we're going to put that in the GitHub environment file, which just comes by default inside of that Ubuntu virtual machine image. There is a fantastic GitHub action called action gh release made by this user softprops, which I will show you here. Go to github.com/softprops/action-gh-release to take a look at this action. GitHub did maintain its own version of pushing something to release in GitHub Actions, but it's since been deprecated, and it seems that this is kind of the new community-maintained version of that. What this allows us to do is it takes something that's in our virtual machine on GitHub Actions and it pushes it to our repository for us, which is really nice, and it creates a new release. Feel free to look through this README to understand how it works, but we're going to use a very basic version of it. There's a lot of powerful commands in here if you want to set app notes, tagging, and so forth, but we're just going to push to a release and use our own app notes that we create so that some documentation comes along with each of our releases. Even though this workflow should not run unless we've checked in a new tag, we generally want to check it again when we use this action gh release. To do that, we're going to use this if statement, and we're going to look within this GitHub context. That is, when we're dealing with a particular, say, commit to GitHub, we're going to look at the reference, which consists of the name and some tags, and we're going to look to see if the beginning of that reference contains tags. That means we're pushing a new tag. So this will only execute if we are pushing new tags. Then we want to make sure we are pushing, in addition to our source code, this compiled binary that should be in the virtual machine. To access the name, we need to go to environment, which is the environment context, and that context was set in this GitHub env file, whatever that refers to. Because the end of that should have been appended with our new app name, we can find this by calling env.appname inside of a $ curly brace, and then we just say .uf2. So this part here should resolve to blink and then .uf2. The simplest way to include some information is to just create a change log and maintain that manually. There are some tools within this ActionGH release that will, for example, look at your various commits and generate a change log, but those may not be human readable or useful to an end user, which is why I might recommend doing the simple approach and just maintaining your own change log. And this can be marked down.
If your life...
So we're done with this YAML, so let's save this. And I'm going to go to the top level of this repository. Let's create our change log that we just talked about. Let's open this. We'll give it a title. We'll just call it the name of the file. And we're going to create our version here. So we're going to create version 0.0.1. And usually a good idea to add the date of release. So today is February 11th that I am recording this. And we are going to write out the features. So you might have features, you might have fixes. So maybe we'll start with fixes. Maybe we'll say none. There were no fixes in this release. And then we'll write out the new features. Maybe this is your first program or your demo or an alpha release or a beta release. Talk about the new features that were added. And in this one, we just created a Blink program and then added a workflow to automatically generate the binaries on each release. In this case, it's not the binaries, it's really the UF2 binary that we're releasing. Feel free to add other binaries. So for example, you could have a .bin, a .hex. I'm showing UF2 because it's easy to just copy right over to the Pico, but you could have like a .bin that gets generated and a user would need to use, say, a vendor-provided tool in order to flash the microcontroller. Or you could get real fancy and have ways to automatically update people's microcontrollers with like over-the-air pushes, but we're not getting into that in this series. This should just give you an idea of how you can start creating a CI/CD pipeline and then expanding from there. Finally, I'm going to create a real basic README here so that you can see this repository in its full context and full glory. I'm just going to paste in what I already have so that you can see how to build it locally. It's everything we just did. You can remove the containers and then a very quick license, which is the zero clause BSD. Nothing special about this README, but it makes the repository look nice. So we're going to save that. We're going to open up our Git bash window or whatever terminal you're using to work with Git. So we made a bunch of files here, which is fine. We're going to add all of our files. I'm going to create a commit with our message here. Initial version that simply blinks an LED. Once we've made that commit, we are going to push. So now we have pushed our repository. So if we go back to Pico deployment demo, you can see all the files here. Everything has been added that we created. However, if we go to actions, nothing is running. That's because we have not created a tag. We have not told our repository that, hey, we're ready to version this. So go ahead and run that workflow. So let's version it. Let's call git tag. And remember, we have to use that v something.something.something. It's looking for that. If we do something else, it's not going to run. It's specifically looking for this template of a tag. So we're going to create that tag, and then we are going to push that tag to origin. there we go. That's all we needed to do to create this new version. Let's go to Pico deployment, go to our actions. There it goes. Our workflow is running. Initial version that simply blinks an LED. That was our commit message. So we go into here, we can go into this particular workflow and see it going. So right now it's building this Docker image. Hopefully you can get an idea of how we might have different workflows. So you might have unit tests, and there are ways to have workflows depend on each other. So you could create a chain. In the previous episode, we talked about unit tests. So maybe you'll run the unit tests first, then maybe you call this deploy.yaml to run a different workflow. So once the unit tests pass, then deploy runs. And you could even have unit tests run every commit and then only run deploy after you have created a version and after those unit tests have run and passed. So you can see how we're starting to create different workflows in order to construct our CI/CD pipeline. So let's go check on this. Let's go to check on build and deploy. And it's still creating our build Docker image. So we'll wait just a moment here. This might take some time, so be patient, which is also probably why you may not want to run this every time you commit, but only on tags. It looks like everything ran, which is fantastic. Let's go to Pico deployment demo. Sure enough, if you look on the right side, you should see releases. Click on that. Here's our change log that we wrote. And here's our assets. So people can download the source code, which is just a snapshot of this repository in time. And here is the binary. So you might have several binaries. So if you're releasing on, say, different operating systems, it might be like a .app or a .exe. If you're working on microcontrollers, this might be a .uf2 or a .bin or a .hex, and allow people to upload it to their microcontroller using a variety of flash tools. So let's click on blink.uf2. That will download it for us. Let's show it in a folder. And if we go to our downloads, there's the one we just downloaded. Remember to hold the boot cell or boot select button and plug in your Raspberry Pi Pico, release that boot select button, and that should pop up as its own drive. So all we have to do for this is copy it. We're going to go to the rpi rp2 drive, and we are going to paste that. And we have just flashed our Raspberry Pi Pico using a binary that we generated on GitHub. Let's see if it works. Sure enough, you can see the LED flashing on the Pico. That concludes our CI/CD series for now. Thanks for coming along with me on this journey, and I hope you learned a thing or two about creating automated tests and deployment for your projects, especially for things like embedded systems. I know we didn't get into hardware in the loop, but that is an advanced topic for a later time. As always, happy hacking!
See him?
Yep. He's still down there. Might have a problem.
Enough flirting. Save it for when we win.
Let's have fun, friend.
Yeah. I vaguely remember that.
That's messed up.
How do you
But
vaguely remember?
No, because it was for the sponsorship, so I had
Wait,
to tweet
can it?
something.
It could have gone A by the way.
And then I refollowed her right away.
Get ready for a light show.
One enemy remaining.
I'm just
I
going.
tanked that for you, Abe. Are you happy?
I'm the jump master.
Yeah.
You're falling for me already.
I hear her
Too
here.
slow.
Charge.
Just kidding. I don't know.
10
It's
seconds
TP.
left.
Eat somewhere.
No, I got your phantom back.
Oh, I was
that was
checking
actually
a
just a
clip
word.
that
Talk
she
to each other
posted.
out
Here,
there.
Saikuno.
Communicate.
Oh, thanks.
Eyes on the prize.
It's so cold.
What the? Keep your eyes peeled. An enemy landing on your knees.
I got snared.
Who's Michael? Phone. Who are you talking to, man?
You should run.
Yes, can see all
Bogey here.
Guys, I'm in danger.
Oh, they're gonna res. They're gonna res mid. They're resing mid. Get all
Oh, nice. Saikuno.
Can't
Another
heal.
one.
I can't. Oh god, I was
Nice.
Dog. I got unbanned in Valorant and it's unsuspended, and then a week later I get suspended again.
Yeah, on site.
The bans were for comms. Like
Do it
what?
to her.
Did you say something bad? Maybe that's why.
The ring is a far distance. 1 minute
Talking to
remains.
his demons. Maybe a lyrics. What's going on, man? Open up shop and shoot them down.
Oh my god!
Let's hurry up and move.
Jeez, I
This is why
blinked.
he shut down the Pixelmon server, so he could smurf on us.
What?
Remember who hooked you up? I've got your back. You are coming home with me tonight.
Let's go. We're on defense first.
Right, I hope your stream is full of positivity, vibes, and happiness. Yeah,
Here's
I
some
won't do
mid.
anything
Yep,
less.
They're going fast.
Need sniper optics. Recharging shields.
There could be a lurk.
One enemy
Holy!
remaining. Spike down.
Ganjan's
Mid.
mad.
Long.
Wow.
Shorty.
Oh,
Shorty
Hey.
saved the day.
that was
Light
fun.
mag here. Level 4.
That was.
I also love mowing them down when they run it in a line.
Lots of those, oddly enough.
I also
See, when
love
you
when
use
they
a
walk
different
in a
gun.
line
Yeah,
and
I
we
didn't
just
have a
mow
stinger
them.
this time. I wouldn't have gotten all of those
Lots
if
of
I didn't
what?
have if I had a stinger.
Yeah, that the ammo.
Well, they might do better on defense. Sometimes it's like that in Valo, you know.
Ooh, I feel good about this care package. Shall we?
Stand here. If they come, she's gonna.
It's like they're doing the same thing but on A.
Oh!
She's doing
They're
the
up
same
ramps already?
thing but on A.
Ooh,
Oh my god.
damn. Coming.
You know what?
Optics here.
Spike planted.
Sniper.
I'll bag that.
Oh, there's upset looking people here.
Sniper stock here. Level 2.
All
There's at
right.
least one in there, one on site.
Shops open.
Oh, that was
VIPs only.
Ow, that hit me.
Nace. I have a. I'm gonna molly the sign.
114 in the corner. Nice.
New kill leader?
Yeah,
Interesting. Mama's got a brand new bag.
faster, right?
Oh.
Ah, get blind. Oh god, the molly.
Player
Oh, what?
In the smoke.
120.
In the smoke.
remaining.
In the smoke. Oh shit.
She's 120.
Okay.
Oh my
Well, that wasn't
goodness.
tough. There's no time, so.
Wow. Let's go.
I know.
They're popping off.
Must be done.
Bandit close by. Visual clear.
Ba-na-na-na-na. Hello,
Copy that.
everyone. Yes, happy 420 to all the potheads out there.
Jump drive in position.
Hostile.
Bonzo. I'm an ex-pothead.
Shooting.
Broke that enemy shield. Reloading.
Shields on that bandit. Reloading. Confirmed splash on whole squad.
What happened?
They're lining up for B. How'd they know I'd peek that?
I heard a KJ stuff.
Oh my god, I just try to hold shift to not fall off there.
Let's check that place out.
Laser sight here. Level 2.
A couple in garage, but nothing crazy yet.
Poison's off. Ooh, half the squads have pieced out. There's the second wind I needed.
Ooh.
Oh my god, the blind. I didn't wait long enough.
They're coming B.
Wait.
In, I think.
Who's ready to fly on a zip line?
They're not in. They're not in. They're just
Activating
left.
jump drive.
Oh. But
They might have rotated. They might have rotated.
KO knifed. KO knifed.
Yeah, KO knifed as well.
They must not be very good.
30
Extended
seconds
light
left.
mag here. Level
Oh!
Whoa!
How did they get hit?
Over rotato. Over rotato. Wait, that means they're.
Oopsies.
Bogey's hurt.
Oopsies.
Got ourselves a bandit out there.
Spike planted.
Charge.
Right here. Revealing area.
Let's check that quadrant.
Shop's open for business.
Site's clear.
Last player
I
standing.
haven't,
mag
haven't.
here.
Or
Level
Raptor,
3.
sorry.
Don't mind if I do.
Yeah, they're panicking. They're panicking.
Oh, I was
Ooh,
just gonna get a half. It's okay. Alright.
Got a bandit in my sights.
New kill
I don't know
leader.
why, but that's stuck in my head. What's it from?
It's the Zed fan.
Oh!
They do have KJ out and I don't have all this time.
Abe, can you buy for me?
Yeah.
I'm insta ulting B.
You're mid.
Replicator on its way down.
When the wall goes down, I'll put mine up. Nice, Sue.
Oh, I thought you got it.
He's got it. Hey!
Hey!
Extended energy mag here.
Sure, they're
Level
already
4.
there.
Only the best for my friends.
Oh, mid as well.
Mid.
Recharged yet.
I'm going back.
Not recharged yet.
I don't see anyone on A, but...
Okay. So 1A main. I'm just gonna stay
Push and
back.
maneuver that area.
Could be up
Yeah, they could be up ramp or.
as well.
Toxins going up.
No, I don't think they went up.
Oh, there was one mid too. Oh, I don't know where that was.
Whoa.
Stairs, I guess? It
Yeah.
had to be.
Yeah, maybe stairs.
Nice.
I think that was a shot from Kevin or.
Last scene was on ramps.
Okay.
Shield battery
That
here.
was the last time I saw it.
Omen.
30 seconds left.
Okay. Okay.
My ultimate's charged and ready to go.
Okay.
I
I'll
think you
just
stay
wait.
B, I'll stay A.
Yeah. I'm so paranoid. Where is she?
Shop's open for business.
I can't chill. It's B. She's smoking B.
Yeah.
Or she has
10
to.
seconds
She has to
left.
stick this.
Yep.
I hear her.
Mama's got a brand new bag.
There you go.
Well
Yay!
played. Very
Oh, that
patient,
was
very
crazy. They were sneaking up
Yeah, they were everywhere.
everywhere.
In the half.
We cannot keep our goods after them. Spend all. Can someone
All right.
get this?
Did we curse ourselves? Monka.
Yes.
Can I get a boy?
Versus.
Courses.
Ray could buy for Abe.
I could
too,
buy.
if Abe needs stuff.
You need some? Okay.
I have
Oh,
Splendid. Sick.
Perfectly splendid.
Okay. Focus, focus.
We're doing great. Only 2 other squads remain.
Vaulted, you can stay.
New kill leader. They can have it. My sights are set higher.
Well, I think that'd be. I don't think we over rotate. Go back to that.
Lucky us.
They're not
we
in
are
yet.
already inside the ring.
We can't leave A.
You guys stay on.
Because they knew I had ult too, so they probably faked it.
A for A.
Yep, they're smoking A right now. I don't. Okay,
Oh,
one's
they're
out.
through.
They're definitely going A with the runner.
Meow. Nice.
I feel good about this
There's one
care
close
package.
now.
Shall we?
On site.
Parting gear.
Power drop in
Prepare
here.
to line your pockets.
Here's good
My
luck.
ultimate's ready.
remaining.
Where?
Heaven.
Ow! Ow! Side.
I was moving so she wouldn't be able to headshot me while I peeked.
Oh, good job, good job. Yeah, that was crazy. That was some
We
good
did, we
dodging.
did
Good
We
dodging,
did
good
it.
dodging.
And now we're cursed.
Yep.
Oh.
Switching sides.
Yeah! Quest!
No. Not the curse.
Replicator
The
incoming.
quest.
Let's make ourselves something
The
nice.
9th quest.
Hostile spotted. Firing. Reloading.
Cracked a bogey's shield.
Don't hey sexy kissy emoji me. Would you say that if I was a carrot?
I am taking fire.
Huh? Would you? If I was a carrot?
I have been down.
Final 2 squads and I don't do second
the
place.
plan?
Cracked a bogey's shield.
Yes.
Got one. Enemy down.
Where you want to wall it?
Yes.
I always get
Well,
Oh, maybe we should leave, right?
We can, but they might have one.
they probably stacked B then. I think we just try to pop mollies. Come to site, come to
Go,
site.
go, go.
Giving my shields a recharge.
Nice.
Oh my god. I did so much. I did
One
everything.
is screen. One is
This is a thick wall.
Oh, another one.
Taking fire.
Nice, nice. Yeah, I can see.
Oh, heaven. One heaven and one wall.
Charging up my shield.
Wait, this wall. Can they get in?
Grappling.
Oh, take.
Making contact with enemy.
On me.
Fire on the enemy.
Playing heaven.
You play crazily. I love it.
¿Dónde estás?
Oh.
Hero to
Recharging shields.
Over here. Got a bandit.
Oh.
Recharging shields.
That's so like fun and relaxing. It's so yeah, 'cause it's just you don't have to worry. You can show the map and everything. It's
Oh, I
awesome.
should probably do that.
Oh, you guys forgot?
What?
Look out, enemy here.
Wow.
Yeah, I'm so relaxed.
Reloading.
Da.
Oh, here, let me.
My Phoenix.
Oh.
I am down.
Oh, careful. There might be someone. Oh, Marcus.
She said go B. She dares me.
Enemy spotted A.
Did they? So they forced, right?
110
Or-
on KJ.
I'll never go B.
Oh, in that corner. Nice. They're grabbing or B. I'm not sure.
I'll never go B. I'm going B heaven. Go B. Go B. I'll trade it.
One more garage.
We have our Apex champions.
Oh, I'm in extreme danger. Extreme danger.
Plus Pika says, surprised face. We're
How are you
top
alive?
two. Nyan plus Pika says, GG.
I can't see. Oh my god, I did it. Oh my god. Jesus. Jesus. Ooh, ooh.
That was so troll.
Ooh.
Bro, how did you die? Did you see the first
That was
shot Leslie
intense.
took?
That was intense.
That bullet
Oh my
went
god.
like northwest.
Yo, did anyone get my POV? I'm not streaming. That was insane. I was John Wick.
That was crazy, crazy, so crazy. That was funny. Okay, am I supposed to have enough for next, or do we just force? Like, how does this work?
I don't know. I kind of just force.
We're so
I'm just
ahead.
gonna force. Charge.
That's so
Somebody's gonna be like, why are you there?
Oh. Okay, there's 2B. There's 2B. One heaven. One heaven. On site.
One enemy remaining.
Here, I'll plant normally.
Guys, we got a knife. Get your knives out. Knives out.
Okay, knifing.
If I see a gun, I'm inting the rest of this game.
Oh God, he's crazy.
I'm just kidding. I'm gonna do that anyway. Get her, guys. Get her.
Oh.
Rush her like zombies. You got her. You got her.
I got her in the knee.
Oh my god.
I got her in the knee.
TP up there?
She TP'd.
That was crazy. We actually rushed her down like
She's
zombies.
so smart. She TP'd on top of a wall.